Alright, so we're going to learn about inverse variations. The learning target says you will be able to identify, write, and graph inverse variations. So what is an inverse variation? It is a relationship that can be written in the form y equals k over x, where k is a non-zero constant and x cannot equal 0. The constant k is called the constant of variation. Okay. So now we're going to see if we can find an inverse variation from two tables. So if we look at the table on the left, we have x as 1 and y is 20. So if we multiply those together, we get 20. If we multiply 2 and 10, we also get 20. And 4 and 5 multiplied together is 20. Okay, so we have now found our k, or our constant of variation, because if we rewrote that equation that we wrote earlier, so we had y equals k over x, we can just rearrange it so k equals y times x. Okay? So that's where we're getting that k value from. So we're multiplying x and y together to get our k. And since our k is constant, and it doesn't equal 0, then this is definitely an inverse variation. So now we're going to the graph on the right. We have 2 and 6, so 2 times 6 is 12. 3 times 9 is 27. And as you can already see, that's not constant, so we don't even have to do our 6 multiplied by 18, because these two numbers, the 12 and the 27, aren't the same. So we already know our x is not, or our k is not going to be constant, so this is not an inverse variation. Okay. So moving on, an inverse variation can also be identified. Oh, this really doesn't like me. It can also be identified by its graph. Stay still. Okay. So an inverse variation can also be identified by its graph. Each graph has two parts that are connected, or not connected. I'm sorry, not connected. None of the graphs contain the point 0, 0. This point can never be a solution of an inverse variation equation. That also has to do with our equation earlier when we said k cannot be 0 and x cannot be 0. So if you look here, we have y equals 5 over x. That's this blue curves shown. The purple is y equals -2 over x. That is the purple curves shown. And the red is y equals 1 over x, and that is the red curves shown. So you see they each have those two pairs that are kind of like mirroring each other, and that are not connected to one another. So now we're going to try and graph an inverse variation in which y equals 2 and x equals 4. Okay, so we said to find k that we could just multiply y and x together. So we have 2 times 4, that equals 8, so k equals 8. So k equals 8. And now we're going to use the value of k to write an inverse variation equation. Okay, so for our equation, we will have y equals, and it's k over x, so 8 over x. That is our equation. So now, we're going to use the equation that we just made to fill in a table of values. So if I can scroll up. Oh, I have a green marker in my hand. We're going to scroll up. So now that we know our equation is y over 8x, I'll rewrite it over here. Y equals 8 over x. Now we're going to create a table of values. So let's choose the value of -4, for example, for x. Okay, so 8 divided by -4, what is that? It is -2. Now let's choose the value of -2. So 8 divided by -2, that gives us -4. And then we'll choose the value of -1. 8 divided by -1 is -8. So then we can go and kind of choose that other side of the number line. So if we have 0, and we put 0 in for x, our fraction in our equation is going to be undefined. So I'm just going to abbreviate it like that. And then we can choose 1. So 8 divided by 1 is 8. 8 divided by 2 is 4. And 8 divided by 4 is 2. Okay, so now we're going to plot those points on this graph over here. So now that we have these points, we're going to plot them on this graph. All right. So we had -4, -2. We had -2, -4. And we had -1, -8. And then we had 0 is undefined. And then we had the point 1, 8. 2, 4. And 4, 2. So now you can kind of see where that curve would be. So we're going to draw it kind of something like this. And this. Okay, and that is our graph. Don't forget our arrows. Alright, so your graph should look something like that. So now, this is the product rule for inverse variation. It says, if x1, y1, and x2, y2 are solutions of an inverse variation, then x1 times y1 equals x2 times y2. Okay, so we kind of saw that earlier when we did our table, where we had our inverse variation graph, or our table, and we had the 1 times, I believe it was the 20, and then the 2 times the 10, and the 4 times the 5. So if we had x1 as that 1, and the y1 as 20, and x2 is 2, and y2 is 10, we notice that when we multiply each of those together, they equal one another, which was 20. So that's kind of all that product rule is saying. So now we're going to use the product rule. So we're going to let x1 be 3, y1 be 2, and y2 be 6. So we are trying to find x2. We say that this y varies inversely as x, so we know this is going to be an inverse variation. So we're going to know that they are going to equal each other. So let's put that into our product rule. So we have 3 times 2 on one side for our x1 and y1, and for our x2 and y2, well, we don't know x2 yet, so we won't fill that in. And then we have our 6 for our y2. Okay? So we know that 3 times 2 is 6. Over here, we're left with 6x2. So to find x2, we divide both sides by 6. And we are left with x2 equals 1. Okay, so that is how we found that.